Our today's speaker is a very senior architect from Cisco with a distinguished career. He's going to be talking about a rather interesting paper. This paper posits a simple idea which has surprisingly high benefits, so a high return on the or sort of efficiency gain um, and practical benefits from a simple idea. So I will let Krishnan Ramaswamy, our senior architect from Cisco, take over now and walk us through this paper.
Hi, everyone. I'm Krishnan Ramaswamy. As Asif said, I'm a senior architect and also a product owner at Cisco on various LLM and GenAI related projects. So a lot of these exciting things happening over the LLMs, it's really getting mainstream in many companies. It's great to know or good to know every day we are encountering new ideas. Today is one such idea, which I think is going to be definitely making an impact in multiple ways. Let me start by sharing my screen. All right. So what I'm going to do today, we are going to go over this paper called the Chain of Draft. And this paper was published probably a few days ago, and it is one of the hot paper in the industry right now. And the main abstract behind the paper is that we have been coming across this technique called chain of thoughts, right? Prompting, which is essentially a technique in all the reasoning models, and also how prompts can be efficiently written to extract the information to during the inference time from the LLM, right? And I'll go through what is this chain of thoughts a little bit to give introduction. But what this paper is attempting to do in a chain of thoughts idea or approach is during the reasoning is very computational intensive, and it produces a lot of tokens. Hence, it needs a lot of what you call LLM inference power to reason the questions or prompt we are asking. But with a new approach, we can optimally or efficiently make the inference, or you can it's called chain of draft, to do the inference much more cheaper, perhaps 30 to 40% improvement over the COT, chain of thought based prompting and inference. Now, why is that significant? If you look at, if you are familiar with today, if you go to any reasoning models, some of you are already, used to, chat with ChatGPT 3.5 or 4. Now you started, interacting with the Poro and Mini and then 3.0 and then many other reasoning models, Gemini, right? Clara. So a lot of these new models that we have been using today is the reasoning models. So the reasoning models, as you know, it is very, you might have seen yourself, it thinks about what to do for your question or your prompt, and it goes into multiple thinking steps, and finally it gets you the answer, right? You might have noticed even for simple questions, instead of giving the answers quickly, it might produce a lot of thinking patterns. At the end, it might come up with the answer. So all this reasoning that you see happening in the LLM is basically a tokens, right? Tokens being sort of inferred by this LLM behind the scene. And people say that compared between the non-reasoning models and the reasoning models, the LLM, things like takes about 10x more tokens than the regular or before reasoning models. So at the end, it costs, right? It's a computational cost, it's energy cost. It's so much of NVIDIA like GPUs need to be utilized for that inference. So now we have a new proposal. So if you think about DeepSeek, just to give an idea, DeepSeek R1 came about a month or so back. At the time, we came to know that DeepSeek had an idea called, it used a chain of thoughts, and also it used GRPO, something like group-based policy optimization, totally to reduce the cost of inference, somewhere in the range of 5x less than compared to other models. So that was a great insight, a great idea. Extending this idea, this another similar idea, right? Chain of draft, which potentially can, again, reduce a lot of computational costs. That's the kind of the idea. Now we go into details. The key theme behind this chain of draft idea is the following. Right, when we think about solving some problem, right, we are not thinking like the way today reasoning model thinks in steps. It goes into elaborate steps, right? But we think in terms of a little bit abstraction, and then some of us might have in our mind some patterns or symbolic based notations or ideas to think through the complex steps. So the whole idea is that instead of telling the LLM, right, do this complex, to solve this problem, do these following steps in this way, that is called chain of thoughts. Why not can we give a cryptic way of telling the LLM? Instead of giving 2-page instructions, can we do it in let's say, few lines of instructions with a very cryptic language? Is it possible, right? So that's the kind of the motivation behind this idea. Reduce the number of instructions we provide for LLMs to reason. By reducing, what you gain is computational efficiency, and then latency, and then performance improvement. So the whole idea is instead of verbose intermediate steps, the chain of draft idea encourages LLMs to be concise and then create a dense information output each step. And then obviously the benefit is huge. It reduces the latency and computational cost. And the paper is demonstrating that it is without much sacrifice. In some cases, it's actually more accuracy. In some cases, a little bit less. But overall, the cost benefit using this idea is tremendous, right? All right, so that's the whole idea. What I'm going to cover in this session is, some of you probably new to this domain, and some of you are already familiar with the COT. So I want to touch upon that. The paper doesn't go into explaining you what is chain of thoughts and all, but in this meetup, we always try to have multiple different, sort of experience comes here. So I give a touch upon the background a little bit, take all of us into some baseline, and then I'll go into the paper reading, and we will end up with how this idea can help you today, right? This idea can help you in your journey today. Some of you are developing the RAG, some of you are into fine-tuning, some of you are thinking about agentic software development, the automation. So this idea can potentially used in any of these, your domain right now. All right, so we'll start with some background knowledge, right? And a lot of this, in support vector, as Asif was saying, we provide a lot of training, and we do meetup, and then in meetups we go through many papers. So obviously, you can think we have reviewed the papers on chain of thoughts, and then tree of thoughts. There are variants of chain of thoughts in the past. You're encouraged to go into that support vector videos page in YouTube, and get familiar with this idea if you're already not, right? And one of the paper we recently had is about DeepSeek R1. In that paper, we'll have some sort of resonate with what we are going to talk today. Mainly, you get more about R1 DeepSeek, but we also I talked about what are reasoning models, what are different prompting techniques, and then what is chain of thoughts. All those things are covered in this paper. Please feel free to watch the video on support vector. Similarly, there are papers we have read called tree of thought and then chain of thought. Again, it is go to the support vector, you get to know. So these are all the different background you may want to familiarize yourself, so that the chain of draft will actually give a more insight and then make a meaningful understanding. All right. So if you are not familiar with that, I just want to show that this is where the support vector YouTube video is there, right? And then you can see a lot of this paper recently. And then we did the DeepSeek R1, or it's a reasoning model. And then there are a lot of things you can go and search on the paper. It's on the YouTube. All right. So what are we going to cover? I'll start with what is chain of thoughts, and then I'll go into directly into paper reading. And paper reading, we'll talk about all these topics. So a little bit on a prompting background, right? So to start with, there are multiple prompting. We all know. We have been playing with the ChatGPT, right? And then some of us who are into the RAG development, and who happen to know what is zero-shot prompting, one-shot prompting. So these are all different techniques. Essentially, it is about how you extract or infer the knowledge from the LLM, right? These are all the techniques. And these techniques are used in multiple ways in your RAG development. And then to reason through the complex tasks that you are in the hand. So you're welcome to go in to read more on that. But our today's interest is two things. One is a chain of thoughts. So because we are trying to prove, this paper is trying to prove, now we have better idea, or which has a better performance and reduce the latency compared to chain of thought. Right. So what is chain of thought? Right, chain of thought is it's a technique in large language models, right, to enhance the capacity of the complex reasoning, right, and then it guides LLM to understand how to reason through the complex task. So that's pretty much is the chain of thoughts, and there are two aspects to the chain of thoughts. People who are already know the RAG, they might use a chain of thoughts, right, based reasoning. I have an example in the coming slides. And then to reason and then get the information from the LLM, right? That's one domain in which the chain of thoughts are applied. Chain of thought based prompting is applied. The another area is, for example, if you take DeepSeek R1, they want to train the large language model, the R1 model. During the training, also the chain of thought approach is used. So that is actually the foundation of DeepSeek R1. If you go back to R1, DeepSeek R1, what they did is they took some base model, and then from the base model, R1 they had a COT, chain of thought based prompting. Optimal. They created the prompts. And then very minimal prompts, maybe like in terms of, I would imagine 100K prompts or something like that. So they use the minimum chain of base prompt and then train the R1 to become, R1 can become a reasoning model. So, what I'm trying to say, it is potentially the chain of thought is used in your client application to reason some complex tasks. At the same way, it can be used by the LLM training to train the LLM. And then you can also include the fine tuning into that. Suppose you want to fine tune a bigger model into a specialized model, or you want to add some domain specific knowledge to the LLM. At the time, you need to train the LLM, right? At that training or fine tuning could be based on chain of thoughts, right? Or it could be based on different prompting technique. So visualize that the chain of thought is in the 3 dimensions. One is in your RAG or agentic application development. One is by the large guys like DeepSeek R1 or other big models. They might use a chain of thought to train their LLM. Third one is the fine tuning aspect. You can also use chain of thought based approach in your fine tuning. Why am I saying that? Now, when we talk about the chain of draft, the same thing applies. You can apply the chain of draft in your RAG agentic application. You can apply the chain of draft in training your LLM. Of course, you can apply the chain of draft in your fine-tuning the LLM. So now we are talking chain of thought. This is just an introduction. Again, if you are familiar with this, please stay, because it is for introducing the chain of thought for other joiners here. So chain of thoughts is very simple, right? In a standard prompting, as you could see that we are asking a question, the answer is coming, right? And then chain of thought, you're essentially training or asking the LLM to think through that. So in this case, Roger, we are training the LLM, giving an example. I'm moving my cursor here. So we are asking the question, Roger has 5 tennis balls, da, 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 right? And then you also tell an example, this is the way you reason through, and then you can ask the question. So I hope you have, if you're played this chain of prompt, you can intuitively get it. So it's basically telling the LLM, yeah, do this way and do these steps, and then you can ask the question slightly differently. It would be able to answer that. So that's a basic concept behind the chain of thought, right? Just to want to note down, if you want to, chain of thought is introduced in this and then enables complex reasoning capabilities through intermediate reasoning steps. You can combine it with a few short prompting to get better results, right? That's pretty much the idea behind that. Once the chain of thought idea is established, right, a lot more ideas came in, right? A tree of thoughts came, and then graph of thoughts is there, and then iteration of thoughts. These are all techniques derived from the chain of thoughts technique. And over the last 1 or 2 years, you might have seen these different techniques. Again, today, our goal is not to go into all of them, but I just want to say that there are many, I have provided some reference in the back about different reasoning techniques. These are all called reasoning techniques, right? And you might ask, where is the tree of thought and the iteration of thought being used? Yes, could be potentially used in some RAG and complex agentic development, or it could be used in LLM fine tuning, right? But chain of thoughts is very popular, very easy to visualize, very intuitive. So still, it's a predominant sort of training system for LLM and as well as for our prompt engineering. Okay, very simple example. This is an example. Again. I don't have the screenshot completely, but just imagine that if you want to train your LLM or fine tune your LLM, you can put the data set like this in a question answer format, and then for this question, you guide the LLM to think through in steps, right? That is example of chain of thoughts used in an LLM training or LLM fine tuning. Okay, so now we are talking background. We are not still gone to the paper. Pretty soon I'll be going. But in the chain of thoughts, extending all the tree of thoughts, there are many other techniques: self-consistency chain of thoughts, skeleton of thought, coconut to train LLMs. The paper is actually addressing that. Now when I refer to the paper, I'm going to talk about these things and concise thoughts. So in the paper, the author is referring to these techniques, saying that after the chain of thoughts, there are other techniques we have developed over the time, but compared to that, chain of draft is still superior to these ideas. So that's a proposal or hypothesis from the paper. Okay, so a couple of more diagrams, then we jump into the paper. So now I'm talking about, now that we know, take a pause and then, okay, it's great. Chain of thoughts is now every reasoning LLMs are using it, and potentially we can also use it in the RAG and agentic development. And then what is the benefit of that chain of drafts, right? In order to illustrate, first we need to think about a little bit about the inference cost, or what we call test time cost. In order to illustrate that, this diagram is illustrating. Imagine the pre-training is the most computational intensive, and then followed by post-training. And then these, imagine the top one is about time spent, energy spent, computation spent during the training. And in the bottom, it's about during the inference when you're making a prompt query, and then that's called inference here. So this is a layout. What it's saying essentially is in the before pre-reasoning model situation, the inference was not that big of a deal. Training part before inference, right? It was a very big deal in terms of computations. So that's what this diagram is saying. And in the reasoning model, now that more and more time is spent on the reasoning, you see that length of that the bottom is increased. So why is it diagram is significant? The idea is with the reasoning model, though the machines are intelligent, LLMs are intelligent, it needs a lot of computations to process, and then go through the intermediate steps, and then finally arrive at the conclusion. So in this type of situation, these reasoning traces or trees are using chain of thoughts based approach for train, and then it uses the same approach for during the inference. In that kind of situation, let's propose the chain of draft, right? And the idea is, can we reduce this computational latency, increase the latency, reduce the computation by 30-40%, and then which in case you can imagine so many GPUs can be potentially utilized in much better way. All right, that's a pitch here. So, and these are all the different other ideas if you want to learn more about chain of thoughts, which is the introduction to this paper. You might want to go through some of the references here. Again, we talked about whatever I'm talking here is actually delivered as the part of the speech for the DeepSeek R1, which is in the recording. Please feel free to see that. So now let's get into the paper. All right. So what I'm going to do, we are going to go through the paper, and we are also going to touch upon some code. I will show you the examples and prompts and some code base, right, as part of the paper reading. All right, you can see the paper reading in full. Yes. Okay. So this paper, actually, it's very simple. The idea is profound, very profound, and idea is very simple. But we are thinking it will make a lot of difference in terms of the optimization and the performance and latency in the future, in the coming future. Okay. So if you look at here, it's only 5 pages, I guess, 5 or 6 pages, right? And then there is a reference to the code. We'll talk from the first. We'll go from top to bottom. So, I will walk through the paper, and I highlighted some key sentences. I'm going to focus on that. And of course, you are encouraged to read later. So in this work, we propose a chain of draft, novel paradigm inspired by the human process, right? Where LLM generate minimalistic and informative intermediate reason. Yeah, it's pretty straightforward. What they are saying is, they are demonstrating later on, it's going to reduce almost by 30% to 35% in terms of the computational cost. But at the same time, it does lag a little bit of efficiency, accuracy, you can say, but it's not much. They have in the worst case scenario about 7% accuracy is lost. And but overall, the cost benefit is tremendously high in favor of chain of draft. All right. So in the introduction, they are, we kind of covered, some of the topic they are trying to introduce the chain of thought. I kind of reviewed with you guys, and then I'm going to skip the introduction here. All right, motivated by this difference, we propose chain of draft, right? A strategy that aligns most closely with human reasoning. What does it mean, right? I can quickly show an example and then take you to here, right? Just hold on for a minute. I will show the example. Once you see the example, you might wonder, wow, is that straightforward, right? That's like a wow factor. So it's interesting that nobody realized this wow factor, but it's very interesting. All right. What they are saying in the paper, we often jot down only the critical piece of the information that helps the progress, right? I think the author is talking about how humans think. And then by emulating this behavior, LLMs can focus on advancing towards a solution without a lot of verbose thinking. Again, that's a pitch, that's a proposal. Yes, we all understand that now. Okay, so let me, before we do that, the authors are pointing out the related work, right? In the related work, as I pointed out, there are so many techniques. Some of the techniques, they are not mentioned here. Recently Stanford released some technique called S1. This is, and then, but bottom line is comes to this. There are, when the reasoning is happening, some of the techniques basically stops the reasoning into a limited set. if you let the LLM to reason, it can reason, let's say, in 20 to 30, 40 steps. But in some techniques, it basically says, don't reason for 40 steps, right? Let's stop in 10 steps. So that is a crude way or one way to minimize the steps of reasoning. And then there are papers came out of that. The paper from Stanford S1, and then some of the ideas mentioned here is about reducing the number of steps globally, right? Globally in the sense without local knowledge, apply that reduce the number of steps technique. That's one type of technique. The other type of technique, it's called coconut to train. It is reasoning in the latent space. If you're familiar with token space and latent space in this LLM, the latent space means all the tokens. Finally, in the LLM memory, if you can go into the LLM memory, you can call it as a latent space. Everything is converted. All our tokens are converted into in a multi-dimensional vector, and then that is called latent space. So the other technique proposed here is, we can use a latent space-based inference, without thinking in tokens. So that's a little bit involved technique, but we are not going into that. But I merely want to point out there are research done in order to reduce the total tokens and reduce the latency. There are techniques in the instead of token space, can we do the reasoning in the latent space? In fact, Asif was planning to cover one such paper pretty soon. That's kind of very involved topic. How do LLMs can think in the latent space? That's another technique. And then there are techniques like concise thoughts and token budget aware LLM reasoning. That's called TAL. So this is a variance of the technique I just mentioned. Reduce the number of steps in somehow based on some tokens. Can I give a token for each session based on the token size? I stop my reasoning steps in some level. Anyway, the point is, there are many, these kind of techniques being invented as we go. But none of them are close to the technique that we are introducing called chain of draft. So it's pretty very simple technique. I will show you here. In the chain of thought, we are basically saying in this example, Jason had 20 lollipops, right? He gave Dennis some lollipops. Now Jason has 12 lollipops. How many lollipops did Jason give to Dennis? And then that's a question. And then we are telling the LLM to think through, right? And then let's think through the steps. Initially, Jason had 20 lollipops, right? Then you're going through the steps like 6 steps here. This is how we can either keep in mind you can use it as a prompting technique or a training technique, for fine-tuning LLM or LLM fine-tuning. Both are same. Essentially, you're telling the LLM, here are the steps, 6 steps to solve this problem. This is what called verbose. This is what industry has been using for the last 1 or 2 years, and then we are proud of that. But suddenly this paper came, and then they said that, wow, that's too much verbose. Right? In some cases, this goes into, I have seen in my company, this kind of chain of thought goes into 4 or 5 pages, right? Instead, can we try this? Just that's all the essence of this paper. Instead of elaborate steps, can I tell the LLM 20 minus x is equal to 12? It's like algebraic thinking or mathematical thinking. Apparently it worked. And then these authors are saying that I don't need to train in a full way. Let me give some mathematical abstraction or mathematical notation or symbolic notation, and then see what happens. And then authors are proving that by this technique, they are able to reduce their token, a number of tokens to train or reason through. And then in this case, you can easily say, right, number of tokens here, you can imagine count it, and the number of tokens here, you count it. It's completely interesting and then groundbreaking, in my opinion, because the cost behind this very, very compelling, right? You can imagine number of tokens it needs during the inference engine is much, much less. I don't know, you can say that 1/20th of this or even 1/50th of this. So that's a technique. Apparently, it just came out of the blue. Nobody thought about this before, but somebody figured out. And that is why the paper is right now all over the internet, and then so many people are trying to give some ideas behind that. With that, that's a key theme behind the paper. Rest of them are details, right? Rest of them are experiments. Now, with this idea, now they did the experiment. I'll go to the experimental results, but why don't we look at the actual code they released, right? The paper showed the idea, and then why not we look at the code? I mean, here code is, the authors are proving that it's actually working, demonstrating it is the fact. And then this code base is very, very simple code base. Anybody can, run it in few minutes or sit down. I mean, basically set up and then run it in a few minutes. You can do that. So what if you go to it's called chain of draft GitHub, right? And then all it needs is all they are trying to prove that is, okay, so let's look at the data before, we don't need to run the code now, right? But what we are looking for is the data. The data is the following. Let's take an example of GSM 8K is one of the testing data set. It's very popular. See, there are many data sets for LLM to test it. And in this case, they used GSM 8K. If you look at that, you'll see 3 files. One is a normal prompt, right? These are the questions. It's all mathematical question or reasoning questions. And then one is if I talk to LLM in a normal way without giving the steps, prompts for that. The second one is a chain of thoughts. I want to talk to the LLM, right, by giving the chain of thoughts. Third one is a chain of draft, right? Let's look at chain of thoughts is about like this. Now you can look at the question, right? Here the question. You can read. This is a question. There are 15 trees in the ground, ... And here is the answer, right? We are walking through that answer. There are 15 trees, ... Right? This is how we are telling the LLM to train themselves. But as you would imagine, in the chain of draft, we are not saying that. We are basically looking at here, and then we are saying 21 trees minus 15, and the answer is 6. Wow. So LLM is able to understand this, and then it can solve similar problems. So it is like teaching a kid, right? Here is an expression, and then you solve all kind of problems within that expression. It's the same idea. To me, it is it's like a wow factor, right? Now we can imagine at the enterprise, you can stuff 4-page instruction, reasoning. I can try to make it in a very concise way, mathematical way or symbolic way. Right? Okay, so rest of them are, in my opinion, details. The real idea is I shared. Then it's all about testing and showing that it works. And then, in some cases it may not work, but let's look at the test results, right? Here, test results, basically when they test it, they test it standard prompting chain, they test arithmetic reasoning and then common sense reasoning. So these are all testing details, but let's take one example. So when they used, okay, there is an example here, right? So they used the GPT-4o, and then if you can read like this, in a standard prompt means like baseline, that's the file. And then COT, obviously COT, chain of thoughts. And you can see what is most interesting is COT accuracy is 95. Of course we don't, but it take about 205 tokens, right? And then latency is 4.2. But look at the chain of draft. Performance is close to 95. It's as close you can say, but the number of tokens is 1/4, and then latency is 1/4. Wow, now this makes a lot of difference, right? And they compared the same thing with the Clara. You can see the same number, right? 192 tokens Clara took, and then this is about 40 tokens. I mean, that proves, accuracy is not lost. It's probably 3-4% lost, but the token inference time need is much 1/4 or 1/5 in some cases. That is for similarly for common sense reasoning, the same thing. Okay, this one is about GSM reasoning, and then common sense is a little bit less, sort of token reduction. We can say 50%, and then but latency. But in the symbolic reasoning, you can see that 28 to 15. So, and then yeah, you can read the results, right? yeah, it is slightly different for different types of reasoning, but in either case, you can say that it is definitely 50% reduction in the token overall, and then you can say 1/3, 1/4, or 1/3 of latency reduction. So that's the whole idea. This is just released very, very recently. I'm sure there will be much more improvements will be coming on that. All right, and then what is the limitation of COD? I think um, the limitation is they figured out, as you could read some of the manual for Clara. Sometimes we have seen that it's not that much reduction in the token. In one case we saw that. In the case of where did we see that? For GPT, the token is 50% reduction. I think token size for Clara, we see that a lot of reduction, and then for the accuracy, sometimes it is less. But in this case, sports understanding apparently good. So again, the way you want to read this, there are 4 different types of reasoning. Right now, the chain of draft behaving slightly different for different reasoning. But you think it in big picture. The big picture is a lot of reduction in the tokens processing. Inference time tokens are reduced to 1/3 or 1/2 in some instance. Hence, the latency is reduced. Performance is not lost. Accuracy is not lost. So that's a high, top message from this paper. All right. We are getting to the end. All right. So the COD now, what is the end? The COD demonstrate that effective reasoning in LLM does not necessarily require lengthy outputs. Lengthy tokens, offering an alternative approach. That's pretty much the bottom line. So going back to the code, you look at all the files on your own, and then see how much reduction in terms of verbose between the COD and COT. And there are different types of reasoning examples are here. So that's kind of the point here. Now going back to our slide. Okay, so the future work, this is a conclusion, right? The future work could explore combining COD with other latency reduction methods, such as adaptive parallel reasoning or multi-pass validation, to further optimize performance across different application domains. In addition, the principles behind this complex reasoning could inspire new strategies to improve reasoning models by training with the compact reasoning data. I covered that, while maintaining the interpretability and efficiency in LLMs, helping bridge the gap between the research-driven improvements in reasoning and the practical demands of real-world systems. Yeah, so altogether, it's a great paper. It's a great insight, and it is another groundbreaking, in my opinion, compared to DeepSeek R1, right? That has its own wow factor, and this paper also definitely have a wow factor, right? And at the end, this is what you can the takeaway from this presentation. If you want to remember one thing, it's about, remember this, right? COT. In the COT, we had question and answer like this format, and in the COD, it's a algebraic notation, right? It's a simple. It could be a symbolic notation. That's a message from this paper, right? COT before and then after COD. That's the key thing, right? And then what's the takeaway? So I think, again, to summarize, right? We talked about COT just to give you a baseline understanding for all of us. And then we talked about the approach and then benefits. Obviously, benefits is clear now. Latency is reduced, right? And then many cases we see 1/4 of the token needs, and then accuracy is not lost. It's only 3-4%. And then, as the author said, they can potentially combine with other approach, to make everything better, right? And we also looked at some sample prompts. And then finally, how you can use it today, right? Think about this idea and go to the GitHub and please try it out on your own. And then if you're developing a complex RAG or agentic application on your own, you may have a good prompts, reasoning prompts or complex prompts. Think about how you can use this notation in this kind of idea to further optimize your prompts. Finally, for the fine tuning, very, very important, right? When we want to do some domain specific fine tuning, this idea will potentially give us more very cryptic form of instructing or helping the LLM to learn. And obviously this will benefit the other bigger players, right? All the big LLM providers, right? They will be, maybe they are already doing, or they will potentially do this. But overall, it will bring the cost down for all of us. All right, with that, I'm going to end. And